Okay, so what I have here is essentially a supplemental review that I'm going to post on my YouTube channel for anyone who is interested in, watching this. Basically, what I have here is this Test 8 review that I made last year for students who came to my FIT. And basically, it just gave gave them the rundown on what's going to be on the test. And I gave them, tips. I gave them, what problems or which problems they should, tackle on first. Like, for instance, do the easy problems and then do the, harder problems. So I'm going to make this video, and this is going to be unedited. It's just going to be posted straight to my YouTube channel once I, finish recording all of this. So, hopefully this, extra thing here is helpful. So, topics on this test: simplifying radicals, multiplying binomials, factoring and solving, the geometric mean, and then there's Hills and Sass. We don't have Hills and Sass on this review. I don't think we had enough time to cover Hills and Sass, but we'll do one example. I'm going to throw one example here that I'm going to make up that's, not already on this document that I made last year. There's going to be Pythagorean theorem, triangle inequality theorem, and then you have to know that Pythagorean theorem and the converse theorems and such, okay? So when you're taking this exam, work on problems you are the most confident on and can finish quickly. Here's my recommendation. And this just varies from student to student. Number one, determine whether the side lanes form a triangle. Those are super easy. If so, determine acute, right, or obtuse. And number two, geometric mean. X is equal to square root of AB. 3, FOIL, multiply. Number 4, simplifying radicals. 5, factoring and solving. When solving, remember the right side of the equation should be 0. Number 6, the Pythagorean theorem. Do the easy one and then the hard. Remember, the Pythagorean theorem is if you're given a right triangle, a squared plus b squared equals c squared, where c is the hypotenuse. And then 7, the Hills and Sass. But, you can follow all of these things in order if you wish, or you can do it however you want. It's your test, it's your grade, but this is my recommendation to you, everyone. Okay, so let's go ahead and take a look at this first problem. I got -5 root 18 times 3 root 12. I'm going to multiply the coefficient to the coefficient and then the radicand to the radicand. So -5 times 3 times root 18 times root 12. So notice that I'm multiplying the coefficient to the coefficient and then the radicand to the radicand. -5 times 3, that's easy. That's -15. And then what I'm going to do is I'm going to multiply these two radicals together like this. Root 18 times 12. That's how I multiply. I'm basically putting all the numbers under one square root. When I mean by all the numbers, I mean the numbers that have a radical under, or basically the radical with them. So -15 root 18 times 12. Okay, let's break down that 18. What I like to do is I need to think of numbers where you want to have a perfect square involved. So rewriting, I have -15, yes? So -15, that drops down. Square root of 9 times 2. 9 times 2 is 18. And then I have 12 over here, which I can break down with 4 and 3. You can see that what I'm going to do is I'm going to underline. I have this here, I have this here and this here. What I'm underlining are the perfect squares in black. So we know what the square root of 9 is. The square root of 9 is 3. So 3 is going to go outside of that square root. So -15 times 3. What else is a perfect square? We have the square root of 4. The square root of 4 is 2. So 2 is going to go outside of the square root. And what remains are the numbers that aren't perfect squares. We have 2 and 3. So I'm going to put 2 times 3. Do you see how I am approaching this problem? When you're taking the square roots of any number, like if I take the square root of 16, that's 4. Great. It goes outside. Nothing remains on the inside because the square root of 16 is a perfect square. But if you have the square root of 16 times 2, well, you know that 16 is a perfect square. 4 is going to go outside. 2 isn't a perfect square, so 2 remains inside of the radical. Okay? Hopefully you understand what I mean by when when you take the square root, you're going to bring whatever that square root of that number is outside of the radical. So let's go ahead and simplify that. I have negative 15 times 3 times 2. Negative 15 times 3 is negative 45. So I can go ahead and put negative 45 here. Root 2 times 3. Oh, sorry. That's not right. This is negative 15 times 3 is negative 45. And negative 45 times 2 is negative 90. So negative 90 root 2 times 3 is 6. So negative 90 root 6 is your answer. Okay? It's also a good idea to, pause, get a piece of paper out, write down the problem, and then work through it, and then, unpause to see if you got the right answer. I mean, that's a good way to prepare for this test, if that makes sense. So I highly encourage you to stop the video right now, get a piece of paper, and then write down the problem, attempt it, and then watch the video to see if you are on the right track when it comes to these sort of problems. Let's do another one. This one is something a lot of people, are stuck on. When you have 6 root 8 over root 3, when you have that radical in the denominator, you have to rationalize. Important that you learn how to rationalize denominators. It's basically simplifying radicals. Or sorry, not simplifying radicals. It's basically simplifying fractions, right? You want to make your numbers look tidy. You want to make sure your numbers look nice. You're basically simplifying. That's the same case with radicals. We have radical rules. We want to make sure our radicals look nice. We want to make sure our answers are exact. We don't want decimals because, sometimes decimals are nice. Sometimes decimals, go on forever and ever. We want to have the exact answer where we don't need to round or anything. We want it exact. So I have 6 root 8 over root 3. What I'm going to do is I'm going to rationalize, meaning that I'm going to multiply the top and bottom by this number here. So I'm going to put root 3 in the denominator, and I'm going to put root 3 in the numerator, and I'm going to start multiplying across. So I have 6 root 8 times root 3. That's going to equal to 6. Sorry, let me use my blue color here. So I have 6 root 8 times root 3 all over the square root of 3 times the square root of 3. Well, if it's the square root of 3 times the square root of 3, that's essentially the square root of 9, which is just 3. So when you're taking the square root, right, and you're multiplying that square root by that same number, or by that same square root, it's basically the number inside of that radical, if that makes sense. So the square root of 3 times the square root of 3 is 3. The square root of 5 times the square root of 5 is 5, and so on and so forth. You should get the pattern here, the gist of that. So square root of 3 times the square root of 3 is 3. Okay? So let me go ahead and erase this. All right, so that is equal to 6 times root 8 times 3 all over 3. And then I'm just going to go ahead and start simplifying the fraction because we have 6 over 3, right? 6 over 3 or 6 divided by 3, that's 2. So I have 2 root 8 times 3. Now, I can go ahead and focus on the stuff inside of the radical. I'm going to break down that 8. I need two numbers that multiply together that'll give me... I need two numbers that multiply together that'll give me 8, where one of the numbers is a perfect square. And I'm thinking 2 root 4 times 2 times 3. Look at that. We have the square root of 4, which is essentially 2, right? So 2 is going to go outside of the radical. And what remain inside the square root are 2 and 3. So your answer is 4 root 6. That's your answer. Okay, let's go ahead and multiply. So, again, when you're approaching the test, you can follow this order if you want. I'm just basically just going to just go in order how the document is presented, but you can do it however you want, okay? Multiply. So you have two binomials. So you're going to FOIL. And FOIL, remember, FOIL means first, outer, inner, last. So first, so 2x times 5x, that's 10x squared. Outside, 2x times negative 9 is negative 8x. Negative 2 times 5x, that's negative 10x. And this right here is your inner. And then now you're going to do the last. Negative 2 times negative 9, that's positive 18. You can see that we can combine the like terms over here because, this is not our answer. We need to combine those two terms there. 10x squared minus 18x plus 18. Let me see. So it's always a good idea to check your work. So 2x times 5x is 10x squared. 2x times negative 9 is... Oh, what happened here? 2x times negative 9 is negative 18. So 2x times negative 9 is negative 18. Negative 2 times... Okay, so then that means that negative 18x minus 10x is negative 28x. Okay? So that's your answer. Good idea to stop and make sure that you are doing this properly. You don't want to go way too fast like how I'm doing it. You want to make sure that you stop and check your work to see if you got that right answer. Otherwise, you're going to get points taken off. Okay? Alright, so let's do this one. You have x plus 12, the quantity squared. So that's basically x plus 12 twice. But sometimes students will make that mistake of taking this 2 when there's a term separated by a plus or a minus sign, and then there's another term. Or if I were to rephrase that, you have two terms separated by a plus or a minus sign, and then they were like, oh, okay, so I have this 2, I'm going to distribute, therefore it's x squared plus 12 squared, which is x squared plus 144. That is absolutely incorrect. What you're trying to think of is this, 4 root 3 quantity squared, and then you can distribute the 2 to each term. That's fine, because you can see that there's no plus or minus whatsoever, okay? But when you see that plus, when you see a term, a sign, and a term inside the parentheses raised to the second power, you need to realize that this is rewritten twice. X plus 12 times x plus 12. Okay? So then, just like what we did before, when you have two binomials, you're going to FOIL. First, outer, inner, last. X squared plus 12x plus 12x plus 144. So you combine the like terms here. So you have x squared plus 14x plus 144. Okay? The trick here basically is, okay, so this is your answer. That's your answer. But the trick here is, if you don't want to rewrite or write x plus 12 twice, okay, if you have something like this, the trick is this. You know for sure that you're going to have x squared as your answer, okay? Then you have to do 12, positive 12 plus positive 12, which is, I think I screwed up. Hold up. Wait. You need to go back. Oh, there we go. I screwed up here because 12x plus 12x is not 14x. That's 24x. My goodness, I'm making all these mistakes here. That's your answer. I'm sorry. All right, now I'm going to go back to what I was trying to say. Okay, so x plus 12, the quantity squared. So you know for sure that you will have x squared as your answer. What I'm going to do is, this middle term is basically this plus itself. So plus 12 plus 12, positive 12 plus positive 12, that's plus 24. And then you slap on the x just like you did when you FOILed. Then you're going to do 12 times 12, and that's 144. Okay? That's the trick. If you have something like x plus 6, the quantity squared, well, you know for sure that you're going to have an x squared as your answer. Then you're going to do 6 plus 6, and then slap on the x. So 6 plus 6 is 12, and then you slap on the x. And then you do 6 times 6, that's 36. So there you go. X squared plus 12x plus 36 is your answer. If I were to give you x minus 8, the quantity squared, well, what are you going to do? Well, you're going to write x squared because you know for sure you're going to have an x squared as your answer after you FOIL. And then you're going to do negative 8 plus negative 8. That's negative 16. Slap on the x. And then negative 8 times negative 8. That's positive 64. Okay? So that's how you FOIL really quickly. All right, let's move on to this. We're going to factor and solve. So, okay, you have 3 terms. This is a trinomial, by the way. It's in the form ax squared plus bx plus c. You have 3 terms. And what's a dead giveaway here is that you have 3 terms, especially in this course, by the way. It's not gonna work every time in Algebra 2, but for this course, if you see 3 terms, just like so, and there is a number in front of the first, that's in the first term, you're gonna factor by the greatest common factor. Factor by GCF. So, if you see this 8, you know that 8 goes into 24 and 144 at the same time. So pay attention to those terms. You have 8a squared minus 3a, and then what's negative 144 divided by 8? Because I have no idea. That's negative 18 equals 0. So you factor by the GCF. Are you done? No, because look at this. You have a trinomial where a is equal to 1. X method is going to be used here. So I'm going to draw an X. C goes up top, and then B goes in the bottom. And I'm going to, first of all, so A is 1, B is negative 3, and C is negative 18. Okay, so put negative 18 up top and then negative 3 on the bottom here. So I need 2 numbers that multiply together. That will give me negative 18 and add up to negative 3. I'm thinking, I don't know, negative 6 and 3, because negative 6 times 3 is negative 18, and negative 6 plus 3 is negative 3. So x minus 6, oh, wait, hold up. Because I'm going to rewrite this now, right? So this is going to be 8 times a minus 6 times a plus 3 equals 0. So I will have, I'm dealing with the variable a, so I put an a here, and then this minus 6 goes here, and then this 3, that's a positive 3, it goes right there. So then we need to examine the left-hand side and the right-hand side. So which values, or what values of a will make the equation true? So if I put 6 here, positive 6, that's one of your answers, because 6 minus 6 is 0, and 0 times anything is basically 0, so the left-hand side equals the right-hand side. And then your other answer should be negative 3, because if I put negative 3 here, negative 3 plus 3, that's 0. 0 times anything is 0, so these are your 2 answers. That's how you solve. You're factoring first and then solving. This one is weird, but basically, when you're solving, you need to make sure that the other side is 0. So 36p squared minus 196 equals 0. If you see something like this, take the square root of this and see if you get a nice number. And take the square root of this and see if you also get a nice number, because you want to know if 36 and 196 are perfect squares. I know for sure 36 is a perfect square, but not many people know that 196 is a perfect square as well. So please, please, please put it in the calculator to verify, to see if you're going to be factoring by the difference of two squares here. So remember, it's basically a pair or two sets of parentheses over here. And okay, what times what is 36? 6 times 6 is 36. What times what is p squared? P times p is p squared. What times what is this minus sign? Plus and minus gives you that negative sign. And then what times what is 196? I hope it's 14. All right, 6p plus 14 times 6p minus 14. Hopefully you see that pattern right there. Oops. And what are you doing? You're going to equal that to 0. So you're going to equal that to 0. So you take this, and you're going to set that equal to 0. So 6p plus 14 equals 0 minus 14 on both sides. So 6p is equal to negative 14. Divide both sides by 6. So p is negative 14 over 6, which reduces to negative 7 over 3. And that should apply to this problem here as well. When you're taking, 6p minus 14 equals 0. Let's do that right now. 6p minus 14 equals 0. Add both sides by 14. So 6p is equal to 14. Divide both sides by 6. So p is equal to 7/3. You have two answers here where one of them is positive and one of them is negative. So that's your answer. Okay? All right, find the geometric mean. So 12 and 30. So in class, I showed you it's essentially a over x equals x over b. So this is a and this is b. So let's fill it in. You have 12 over x equals x over 30. And you have a ratio equals a ratio. So you know that these two ratios are proportional to each other. So cross multiply x times x is x squared. And then I'm going to equal that to 12 times 30. So 12 times 30. Take the square root on both sides. Don't multiply 12 and 30 because you're going to be asked to simplify. I don't want decimals. I don't want decimals on this exam. You're not going to be giving me a decimal on this exam that you're going to take. You're just going to simplify the radical as we've been doing in class. So take the square root of x squared. That's x. That's equal to the square root of the square root of 12 and 30. I'm going to break that down. 4 times 3. Look at that. 4 times 3, where 4 is a perfect square. That's awesome. Then you have this 30, which, 10 times 3. That's great. 10 times 3 is 30. I have the square root of 4. That's 2. And then I have the square root of 3 times 3. Square root of 3 times 3. The square root of 3 times 3 is the square root of 9, which means that 9 is a perfect square, and therefore the square root of 9 is 3. So 3 goes outside of the radical. What remains inside? That's the 10. So x is equal to 6 root 10. That's your answer. Okay. Hopefully you got that. And then over here, we have to find the geometric mean between 1/4 and 24. So I'm going to go ahead and shortcut this. It's x equals the square root of a times b. So here's a, this is b. So 1/4 times 24. Okay, so over here, I didn't multiply these two numbers because these are whole numbers. But over here, I have a fraction and I have a whole number. In fact, I'm actually going to multiply that because it's hard to take the square root of a fraction if you could just multiply, and whatever the result of that, you can take the square root. Because 1/4 times 24, you're going to get a smaller number. Okay? So x equals to 1/4 times 24. 24 divided by 4. That is 6, right? It should be 6. Oh, x equals the square root of 6. Can I simplify this? Let's see. So 3 times 2. 3 doesn't have a pair. 2 doesn't have a pair. So your answer is really x equals the square root of 6. Okay, that's your answer. All right, Pythagorean theorem. All right, so Pythagorean theorem, find x. You know, with the Pythagorean theorem, if you are given a right triangle, a squared plus b squared equals c squared, you're not going to use Hills and Sass for this one because there's no altitude involved. So use the Pythagorean theorem. Know what's a, what's b, and most importantly, know what c is. And remember, c is always across from the 90-degree angle. Okay, so c is 5. So I can go ahead and plug that in. So 5 squared, yes? And then this is A, this is B. You can call this A, you can call that B. It doesn't matter, it doesn't change anything. But what's important is that you know what C is. C is 5 in this case because it's across from the 90-degree angle. Okay? So I have x minus 1 quantity squared plus x squared equals 5 squared. And then I have x minus 1 the quantity squared, which is basically x minus 1 times x minus 1. Or, remember, I showed you the faster way of doing this. You know for sure when you FOIL, you're going to have x squared as, part of your answer. Then you're going to do negative 1 plus negative 1. That's negative 2x. Remember, it's negative 2, right? And then you slap on the x, and then you're going to do negative 1 times negative 1, which is positive 1. Negative times a negative is a positive. Negative 1 times negative 1 is positive 1. Okay, so this is basically that. For this one, however, we're going to put plus x squared. So nothing changes there. I'm just dropping that down, and I'm going to equal that to 5 squared, which is 25. All right, so note, how many x squareds do we have? Because now what I'm doing is I'm going to check to see if I can combine any like terms. Notice that we have an x squared here and an x squared here. I'm adding those, like terms there. So it's x squared plus x squared. So I have 2x squares. Then I'm going to go ahead and bring down the minus 2x plus 1, equal that to 25. Okay? Now, this is where students get stuck because they get to this point and they have no idea what to do. So first of all, what do you see? You see a trinomial. It's in the form ax squared plus bx plus c, and it's equal to some random number. This is where you are factoring and solving just like what we did over here. You need to make sure that the other side is equal to 0. Okay? So, going back, get this side equal to 0. I'm going to minus 25 on both sides. You get 2x squared minus 2x plus positive 1 minus 25. That is, sorry, that's not plus. So it's 2x squared minus 2x minus 24 equals 0. And then look, you have that trinomial. It looks like what you can do is factor a 2 out. 2 times x squared minus x minus 12 equal to 0. And again, look at that. Look at this right here. That's a trinomial. You're going to use the x method. C goes up top, B on the bottom. Negative 12 and then negative 1. Think of the two numbers that multiply and add. I'm thinking negative 4 and 3. So 2 times x minus 4 times x plus 3 equal that to 0. So x is equal to 4. X is equal to negative 3. And please don't give me your answer as x plus 4 and x minus 3. I don't know why people do this. Just don't do that. That makes no sense to me when you know that your expressions are x minus 4 and x plus 3. But, just take this, equal that to 0, solve for x, and do the same thing for x plus 3. Okay? All right. Now, context of this problem. You are dealing with a geometric figure. So that means you're dealing with x minus 1, and 5. Notice that these are the side lengths, and side lengths are always positive. So tell me, what is the best answer? The best answer here is x equals 4 because, number 1, that's your positive answer, and number 2, if you plug it in, 4 minus 1, that's 3. And then here, this is 4. If you plug in that negative, you're going to have a negative side length here and a negative side length there, which we do not want. We don't want that whatsoever. So chop that negative 3 away, and then be happy that you figured out the answer for this problem. Okay, even though I went over this problem, I highly recommend that you get a separate sheet of paper and do this problem like twice. So you have an idea on how to approach this problem where you know what you're doing and you know the steps, okay? I need you to be comfortable with knowing how to approach and know how to do the steps when it comes to, Pythagorean theorem and factoring and solving, okay? So that's all for that one. What do I have here? I have extras. Oh, cool. Determine if each set of numbers can be measures of a triangle. If so, determine if the triangle is right, acute, or obtuse. 13, 5, 8, and 10. Okay, so is it a triangle? Yes or no? And you're going to tell me the type. Okay, so first of all, I'm going to take this set, and I'm going to write 10, 8, and 5. So big number, medium number, and then smaller number. Then you're going to tell me the two numbers that are not 10 from this set, 5 and 8. So 5, and you're going to add 8, and you're going to compare the left-hand side to the right-hand side. Is the left-hand side greater than the right-hand side? So 5 plus 8, that's 13. That's indeed greater than 10, so put a check mark there. Okay, 8... 5 and 10. I don't need to add 5 or I don't need to know what 5 plus 10 is because I know that 10 is greater than 8. So that inequality holds true. And then lastly, we have 5. So the numbers not 5 are 8 and 10. So 8 plus 10. Again, I don't need to add 8 plus 10 because I know that 10 is greater than 5. And also, look, 8 is greater than 5. So this inequality holds true. So if all the inequalities hold true, you have formed a triangle. That's a yes. But what type of triangle is that? You're going to do c squared blank a squared plus b squared. Okay, remember that. I like to have c on the left-hand side. A lot of people put c on the right-hand side or c squared on the right-hand side, and hopefully you know what you're doing. Hopefully you're not picking the wrong type of triangle. But if you want to stay on the safe side, put c squared on the left-hand side when you're determining what type of triangle that is, okay? Let's see. So what the heck is c? So c is always the longest side of the triangle. C is always the longest, no matter what. C is always the longest side. So you're going to do 10 squared blank, and this is A and this is B. So 5 squared plus 8 squared. 10 squared is 100, and the 5 squared is 25, and this here is 25 plus 8 squared, that's 64. Okay. So 25 plus 64, that is 101? Is that one? No, that's not 101. What is that? That is, sorry, I'm blanking. 89. What am I doing? That's easy math. Okay, so that's 89, and then I'm comparing that, I have 100, and I'm comparing that to 89. 100 seems to be less than 89. So if that's less than, that's acute. Okay, if c squared is less than the right-hand side, it's acute. Okay? All right, so let me go ahead and rush through 14. So I have 4, 20, and 8. So 8 plus 20 is definitely greater than 4. And then, let's see. 8 plus 4, is that greater than 20? Nope, it's actually less than, because 8 plus 4 is 12, and 12 is less than 20. So this, you cannot form a triangle. It's a no. All right. Oh, and by the way, if it's a no, you don't write anything here. Do not write if it's a no. Okay? Let's look at 15. I'm going to do 10, 8, and 7. So 7 plus 8, is that greater than 10? Yes. 8. Let's see, 7 plus 10, that's greater than 8. And then lastly, 8 plus 10, that's greater than 7. So all of the inequalities hold true. It's a triangle. You can circle yes. And then you're going to figure out what type it is. So this here is A, B, and C. C is the longest side. So 10 squared blank, A squared plus B squared. That's 100. That's 100. And then you have 49 plus 64. What the heck is 49 plus 64? Again, I'm not good with my arithmetic. I can't do math in my head. I use a calculator just like a lot of y'all, which is totally fine. 100 compared to 113. Okay, now look. Left-hand side compared to the right-hand side. Is the left-hand side greater than, equal, or less than? Well, 100 is less than 113. So, again, this is acute. That's acute. Now, if this was, I don't know, 25. Let's say you're comparing the left-hand side to the right-hand side. If you're comparing 100 to 25, obviously 100 is greater than. If 100 is greater than, or if your c squared is greater than, you're going to write obtuse. Okay? But in this case, it is acute. All right, 3, 4, 5. Let's do it. 5, 4, 3. 3 plus 4 greater than 5. Yes, that holds true. And then 4, we have 3 plus 5. That's greater than 4. That holds true. And then lastly, 4 plus 5. That's greater than 3. That holds true. So you have a triangle here. Okay? Perfect. You have a triangle. Now, what type of triangle is this? So look at your set. Tell me what the longest side here. In this case, it's 5. So you have c squared blank a squared plus b squared. C is 5 squared. And then a is 3 squared plus b squared. That's 4 squared. So 25 blank 9 plus 16. 9 plus 16 is 25. Look, the left-hand side is equal to the right-hand side. That's a right triangle. It's equal. Again, if the left-hand side is equal to the right-hand side, you know for sure that it's a right triangle. And remember, with the Pythagorean theorem, you're dealing with a right triangle, therefore a squared plus b squared equals c squared. And notice that when you're thinking about that theorem, a squared plus b squared equals c squared, that left-hand side should equal to the right-hand side. Okay? And the converse does hold true when it comes to the Pythagorean theorem. And the converse is essentially if a squared plus b squared equals c squared, then it's a right triangle. Or in this case, if c squared is equal to a squared plus b squared, then it is a right triangle. Okay? Wow, look at all that. That's a lot of scribble scrabble right there. That's awesome. Okay, technically I am done with the review, but notice that we don't have any Hills and Sass here. So let me just scroll down here and look at that. You are going to be dealing with a Hills and Sass on the test, so no doubt about that. But how do you know if you're supposed to do Hills and Sass? Look at your triangle, and if you see an altitude that drops, or, you know, something like this, then you're dealing with the right triangle proportion. Okay? Always, 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 always write H, L1, L1, S1, H, L2, L2, S2, and then segment 1, altitude, altitude, segment 2. Okay? This is your organizer. This is your organizer. But you can't organize without labeling the figure, so let's label. Remember, across from the 90-degree angle, you got yourself a hypotenuse. And how long is the hypotenuse? Well, if I do part plus part equals whole, 4 plus 9, that's 13. Your hypotenuse is 13. And then you have a part plus part that's going to constitute that hypotenuse there. So this is segment 1, segment 2, and then the sides that are not the hypotenuse, we call them the legs. So leg 1, leg 2. Remember, be consistent. Look at this triangle here. We called this segment 1 for that triangle. So that means that you call this segment leg 1. If you call this segment 1 and then leg 2, you basically messed up. Don't do that. Okay? So hypotenuse, segment 1, segment 2, leg 1, leg 2, and then one more thing, that's the altitude. Okay? This here is the altitude. So let's go ahead and fill everything in. H is 13. So for all the H's that you see, write 13 underneath. Leg 1 is X. So again, for all the leg 1s that you see, write X. Segment 1. Where's segment 1? That's 4. So I put 4 here and a 4 here. Leg 2. That's Y. So Y here, Y there. And then segment 2 is 9, so 9 here, 9 there, and then lastly the altitude is Z. So Z here, Z there. So, let me go ahead and create my proportion. Remember, the proportion is, for, hills with a subnotation 1, is H over L1 equals L1 over S1. So 13 over x equals x over 4. Cross multiply. So you have x times x, that's x squared. And that's going to equal to 13 times 4. Take the square root on both sides. X is equal to 2 root 13. For this one, I do 13 over y equals y over 9. So y squared equals 9 times 13, take the square root, y is equal to 3 root 13. Okay, look, taking the square root of 9, you know what the square root of 9 is. That's 3, so 3 goes outside, 13 remains inside. And then this one here is 4 over z equals z over 9. So z squared equals 9 times 4. Take the square root. Z equals, I have 2 perfect squares. So the square root of 9 is 3, and the square root of 4 is 2. So z is equal to 6. That's your answer. And I basically got this problem from the Hills and Sass notes. Anyways, good luck with your studies.